Hey there, and welcome back to another episode of Boring History for Sleep. Tonight, we're taking a quiet walk through the ancient streets of Rome, a world without electricity, yet filled with marvels of engineering and design. Together, we'll drift slowly through the calm rhythms of a civilization that built cities with nothing but patience, planning, and a whole lot of hands-on labor. We'll sit beside the surveyors sketching empty hillsides, listen in as engineers whisper calculations about water flow, and watch the silent work of countless builders shaping stone and mixing concrete, one careful motion at a time. Before we begin, go ahead and like the video if you find comfort in these slow, gentle stories, and subscribe if you'd like more history that helps you wind down. Let me know in the comments where you're listening from and what time it is for you. It's always lovely to see this little community from all corners of the world. Now, take a deep breath, dim the lights, maybe turn on a fan or a soft rain sound in the background, and let's slip quietly into the ancient world where cities rose slowly under the Mediterranean sun. The Roman Empire stretched across 3 continents, from the foggy borders of Britain to the sun-baked shores of North Africa, from the Atlantic coast of Spain to the fertile valleys of Mesopotamia. Across this vast expanse, Roman engineers and architects built hundreds of cities, each one a testament to human ingenuity operating without the benefit of modern power. These cities rose from empty fields and hillsides through careful planning, patient construction, and the steady application of hand tools, animal power, and human muscle. Every street was paved stone by stone. Every aqueduct was surveyed mile by mile. Every building was constructed block by block, with workers climbing wooden scaffolds and hauling materials by hand to the upper levels of multi-storied buildings. When we think of Roman cities, we often picture the grand monuments and towering structures that still stand today. The Colosseum, with its complex network of passages and chambers. The Pantheon, with its massive concrete dome. The Forum Romanum, with its marble columns and elaborate facades. But beneath these impressive structures lay a complex network of infrastructure that made urban life possible. Water flowed through carefully engineered aqueducts that stretched for dozens of miles across the countryside. Waste moved through elaborate sewer systems that could handle the daily needs of hundreds of thousands of residents. Streets were paved with precisely cut stones that fit together like puzzle pieces, creating smooth surfaces that could withstand the constant traffic of carts, horses, and pedestrians. All of this was accomplished without electric lights to illuminate the work sites during long winter nights, without power tools to speed the cutting and shaping of stone, without mechanical equipment to lift heavy materials to the upper levels of multi-storied buildings, without electric pumps to move water uphill or fans to ventilate underground workspaces. The Romans built their cities using techniques that had been developed over centuries, refined through experience and passed down from master craftsmen to apprentices who learned their trades through years of patient practice. The Romans built their cities according to principles that had been refined over centuries of urban development, They understood that a successful city needed more than impressive buildings and wide streets. It needed clean water flowing reliably from distant sources. It needed efficient drainage to carry away rainwater and human waste. It needed safe streets where citizens could walk without fear of collapse or flooding. It needed spaces where people could gather for commerce, worship, and social interaction. They knew that the location of a city mattered as much as its construction, and they carefully selected sites that offered natural advantages while avoiding potential problems that could threaten the health and safety of urban residents. Geography played a crucial role in Roman urban planning, and site selection was the first and most important step in founding a new city. The Romans preferred to build their cities on elevated ground when possible, as hills provided natural defense against military attack and improved drainage during heavy rains. They looked for locations near reliable water sources, whether rivers that flowed year-round, natural springs that produced clean water, or lakes that could supply the daily needs of a growing population. They considered the prevailing winds and how they would affect the comfort of residents and the dispersal of smoke from cooking fires and industrial activities. They examined the quality of the soil, both for construction purposes and for agricultural production in the surrounding area. They thought about trade routes and how the city would connect to other urban centers and rural regions. They considered military factors, including defensive positions and proximity to potential threats. All of these factors were weighed carefully before the first foundation stone was laid or the first street was marked out on the ground. The process of founding a new Roman city followed established rituals and procedures that had been developed over centuries of urban planning experience. Surveyors would arrive first at the chosen site, carrying their bronze instruments and wooden measuring tools. They would spend days or weeks mapping the terrain, noting every hill and valley, every stream and rock outcrop. They used a bronze instrument called a groma, which consisted of a vertical staff with horizontal crosspieces that helped them create perfectly straight lines and precise right angles. They carried measuring rods made of wood or bronze, carefully calibrated to standard Roman units of measurement. They used ropes and chains to mark distances across the landscape. They observed the sun and stars to determine cardinal directions with remarkable accuracy. Working slowly and methodically, often in conditions of extreme heat or cold, they would lay out the basic grid pattern that would guide all future construction in the new city. Roman cities were typically organized around two main streets that intersected at the center of the urban area. The north-south street was called the Cardo Maximus, while the east-west street was known as the Decumanus Maximus. These primary thoroughfares were usually wider than the other streets in the city, sometimes wide enough for two carts to pass each other comfortably, and they served as the main arteries for traffic and commerce. The Cardo and Decumanus were paved with the finest materials available, often featuring sidewalks for pedestrians and gutters for drainage. From this central cross, a grid of smaller streets extended outward in all directions, dividing the city into rectangular blocks called insulae. Each insula was typically about 100 Roman feet on each side, though the exact dimensions could vary depending on local conditions and the intended use of the buildings within each block. The Forum occupied the heart of every Roman city, typically located at or near the intersection of the Cardo Maximus and the Decumanus Maximus. This central square served as the commercial, political, and social center of urban life. Here, citizens gathered during the day to conduct business, participate in political discussions, and socialize with their neighbors and visitors from other cities. The Forum was surrounded by the most important buildings in the city, including temples dedicated to the major gods, basilicas that served as courts and meeting halls, and government offices where local officials conducted the daily business of municipal administration. The Forum was paved with stone, often marble or other expensive materials, and was frequently decorated with statues of emperors, local dignitaries, and mythological figures. Fountains provided fresh water and created pleasant sounds that masked the noise of commerce and conversation. Water was the lifeblood of any Roman city, and the Romans developed sophisticated systems for bringing fresh water from distant sources and distributing it throughout the urban area. The aqueducts are perhaps the most famous examples of Roman engineering, but they were just one part of a complex water management system that included distribution networks, storage facilities, and waste removal systems. The Romans understood that cities needed not just a supply of clean water, but also effective ways to distribute it to every neighborhood and building, and reliable methods for removing wastewater and sewage to prevent contamination and disease. The construction of an aqueduct began with careful surveying to determine the best route from the water source to the city. Roman engineers needed to maintain a gentle downward slope over distances that could stretch for dozens of miles across varied terrain. They used a device called a corabates, which was essentially a long wooden frame with a water level built into it to ensure that the gradient remained consistent throughout the entire length of the aqueduct. The work was slow and painstaking, requiring constant measurement and adjustment as the construction crews worked their way across hills, valleys, and plains. Every few hundred feet, the surveyors would check their measurements and make corrections to ensure that the water would flow properly when the aqueduct was completed. Most aqueducts were built as covered channels that ran along the ground or through underground tunnels carved through hillsides. The popular image of Roman aqueducts as tall stone arches crossing valleys represents only a small portion of these massive construction projects. The arched sections, known as arcades, were used primarily to carry water across valleys or other obstacles where ground-level construction was not practical or economical. The majority of aqueduct construction involved digging channels through soil and rock, lining them with stone or concrete to prevent leakage, and covering them with stone slabs to prevent contamination from surface water and debris. The workers who built the aqueducts used simple tools that had remained essentially unchanged for centuries. They dug with wooden shovels tipped with iron, broke rock with hammers and chisels, and moved earth in wicker baskets carried on their backs or loaded onto wooden carts pulled by oxen. The work was physically demanding and often dangerous, especially when workers had to excavate tunnels through solid rock or work on scaffolds high above valley floors. Progress was measured in feet per day rather than miles, and major aqueduct projects could take years or even decades to complete. The aqueducts flowed into distribution tanks called castellae aquae, usually located at the highest point in the city where gravity could be used to distribute water throughout the urban area. From these tanks,
A network of lead and ceramic pipes carried water to public fountains, private homes, and commercial establishments throughout the city. The Romans understood the principles of water pressure and used them to their advantage, designing systems that could deliver water to the upper floors of multi-story buildings and create decorative fountains that shot water high into the air. The lead pipes used in Roman water systems were manufactured by skilled craftsmen who shaped sheets of lead around wooden forms and soldered the seams to create watertight joints. The pipes were available in standard sizes, with the diameter determined by the volume of water that needed to be carried. Larger pipes were used for main distribution lines, while smaller pipes served individual buildings. The installation of the pipe network required careful planning to ensure adequate water pressure throughout the system and to minimize the risk of contamination or damage.
Public fountains were strategically placed throughout Roman cities to ensure that all residents had access to clean water within a reasonable walking distance of their homes. These fountains operated continuously, with fresh water flowing in at the top and overflow water carrying away any contamination that might accumulate. The constant flow also helped maintain water quality by preventing stagnation and provided a reliable supply even during periods of peak usage when many people were drawing water simultaneously. Many fountains were elaborately decorated with carved stone figures, bronze fittings, and architectural details that made them attractive gathering places for residents of the surrounding neighborhood. Roman cities also featured numerous public bathhouses, which were among the most sophisticated buildings in the ancient world. These complexes, known as thermae, included rooms heated to different temperatures, swimming pools filled with water of varying temperatures, exercise areas where citizens could participate in athletic activities, and social spaces where people could relax and converse with friends and acquaintances. The heating system used in these buildings, called a hypocaust, used furnaces to warm air that then circulated through spaces beneath the floors and inside the walls. Slaves tended the fires continuously, feeding wood and charcoal to maintain comfortable temperatures throughout the complex, even during the coldest winter weather. The engineering of Roman baths required careful planning and skilled construction techniques adapted to the specific requirements of these complex buildings. Hot air from the furnaces needed to be distributed evenly throughout the building, while water had to be heated to precise temperatures and delivered to the appropriate pools and chambers. The Romans accomplished this through a combination of lead pipes, bronze fittings, and carefully designed air circulation systems that moved heated air through the building without creating dangerous concentrations of smoke or carbon monoxide. The work was all done by hand, with workers using simple tools to install the complex network of pipes, ducts, and heating chambers that made these buildings function properly. The floors of Roman baths were supported on small brick or stone pillars that created spaces for heated air to circulate. These pilae, as they were called, were carefully spaced to provide adequate support for the floor above while allowing air to flow freely throughout the space. The walls contained hollow chambers called tubuli that carried heated air from the hypocaust system to vents near the ceiling. The construction of these systems required precise measurement and skilled masonry work to ensure that the heating system would function efficiently and safely. Waste management was another crucial aspect of Roman urban planning, and the Romans built extensive sewer systems to carry away human waste, rainwater, and runoff from the streets. The most famous of these systems was the Cloaca Maxima in Rome itself, a massive sewer that could handle the waste from hundreds of thousands of residents. But similar networks existed in cities throughout the empire. These sewers were marvels of engineering, designed to handle large volumes of water and waste while preventing backups and overflows that could contaminate the urban environment. Roman sewers were typically built as stone-lined tunnels that were large enough for workers to walk through for maintenance and cleaning purposes. They were designed with careful attention to slope and flow rates, ensuring that waste moved efficiently toward rivers or other disposal points outside the city. The construction required skilled stonework and waterproofing techniques, as well as careful planning to connect the sewer network to individual buildings and public facilities throughout the urban area.
The workers who built Roman sewers faced some of the most challenging conditions in ancient construction. They worked in cramped, poorly ventilated spaces, often in complete darkness, illuminated only by oil lamps or torches. They had to excavate through various types of soil and rock, shore up tunnel walls to prevent collapse, and install the stone lining that would contain the sewage flow. The work was not only physically demanding, but also dangerous, as workers faced risks from cave-ins, toxic gases, and flooding. Street construction in Roman cities followed standardized practices that created durable, well-drained roadways capable of handling heavy traffic for centuries. Roman streets were typically built in multiple layers, starting with a foundation of large stones called statumen, followed by a layer of smaller stones and gravel known as rudis, then a layer of concrete or mortar called nucleus, and finally topped with carefully fitted paving stones called summa crasta. The surface was slightly crowned in the center to encourage water runoff, and gutters along the edges carried rainwater to the sewer system or to drainage areas outside the city. The paving stones used in Roman streets were cut and fitted by hand using simple tools that required considerable skill to use effectively. Stonemasons used hammers and chisels to shape each stone to fit precisely with its neighbors, creating a smooth surface that could withstand the constant traffic from carts, horses, and pedestrians. The stones were typically made from local materials, often volcanic rock that was both durable and relatively easy to work. Each stone was carefully measured and positioned to create the proper slope for drainage while maintaining a level surface for wheeled vehicles. The work of paving Roman streets was time-consuming and required considerable skill and experience. Each stone had to be individually shaped and fitted, a process that could take hours for a single stone, depending on its size and the complexity of the surrounding pattern. The workers used wooden mallets to position the stones and iron tools to make final adjustments to the fit. Sand or small gravel was used to fill gaps between stones and provide a stable base for the paving surface. Roman cities accommodated various types of traffic, from pedestrians carrying goods to heavy carts loaded with construction materials or agricultural products. Streets were designed with different widths to handle different types of use and traffic volume. Major thoroughfares like the Cardo and Decumanus
were wide enough for two carts to pass each other comfortably, while smaller residential streets might accommodate only pedestrians and pack animals. Some streets included raised sidewalks made of stone or concrete to separate foot traffic from wheeled vehicles and provide safe passage for pedestrians. The Romans also developed systems for managing urban traffic flow that helped prevent congestion and accidents in busy commercial areas. Certain streets were designated for specific types of use, with restrictions on when heavy carts could enter areas near the Forum or other crowded districts. These regulations were enforced by local officials called ediles, who monitored compliance and issued penalties for violations. The goal was to keep goods moving efficiently through the city while maintaining safe conditions for pedestrians and residents. Traffic control in Roman cities also involved the use of stepping stones placed at regular intervals across major streets. These stones allowed pedestrians to cross muddy or wet streets without soiling their feet or clothing, while the gaps between them were wide enough to accommodate the wheels of carts and wagons. The stones were carefully positioned to match the standard spacing of Roman cart wheels, ensuring that vehicles could pass over them without difficulty. Roman construction techniques relied heavily on manual labor and simple tools that had been refined over centuries of use. Workers used iron hammers of various sizes for different tasks, from heavy sledgehammers for breaking stone to small tack hammers for delicate work. Chisels made of hardened iron were used to shape stone and wood, with different blade widths and angles for specific applications. Saws with iron teeth cut through wood and soft stone, while planes smoothed wooden surfaces. Hand drills bored holes for wooden pegs and metal fasteners. Stone was the preferred building material for important structures in Roman cities, and local quarries supplied limestone, marble, travertine, and other stones that were cut and transported to construction sites throughout the urban area. The work of quarrying and shaping stone was entirely manual, requiring skilled craftsmen who could split large blocks from the quarry face, transport them to the construction site, and shape them to exact specifications. Each piece was carefully measured and fitted to ensure structural integrity and aesthetic appeal. The process of quarrying stone began with the identification of suitable deposits and the development of access roads to transport the finished blocks. Workers used iron wedges and hammers to split stone along natural fracture lines, a technique that required considerable experience to avoid damaging the stone or creating pieces that were too small to be useful. The blocks were then shaped using hammers and chisels, with the final finishing work done at the construction site where the stone would be installed. The Romans also pioneered the use of concrete in construction, developing a mixture of lime mortar, volcanic ash called pozzolan, and aggregate that was stronger, more durable, and more economical than stone construction. Roman concrete was mixed by hand in wooden troughs, with workers using hoes and shovels to combine the ingredients until they achieved the proper consistency. The concrete could be poured into wooden forms to create complex shapes and structures that would have been impossible or prohibitively expensive to construct using stone alone. The development of Roman concrete was a gradual process that took place over several centuries as builders experimented with different combinations of materials and techniques. The addition of volcanic ash from deposits around Mount Vesuvius and other volcanic areas created a concrete that was not only strong, but also resistant to water damage, making it ideal for use in aqueducts, harbors, and other structures that would be exposed to moisture. Scaffolding systems enabled Roman builders to work at height safely and efficiently, allowing them to construct multi-story buildings and tall monuments. These temporary structures were built from wood and rope, assembled piece by piece as construction progressed upward. Workers climbed wooden ladders to reach working platforms that were suspended above the ground on frameworks of timber posts and braces. The scaffolding was designed to support not only the workers, but also the materials and tools they needed for their tasks. The construction of scaffolding required careful planning and skilled carpentry to ensure that the structure would be stable and safe under the loads imposed by workers, materials, and construction activities. The wooden components were joined using traditional woodworking techniques, including mortise and tenon joints, wooden pegs, and rope lashings. The entire structure had to be designed to be dismantled and moved as construction progressed, requiring flexibility and adaptability in the design. Roman builders used various lifting devices to move heavy materials to upper levels of buildings, overcoming the limitations of human muscle power through mechanical advantage. Simple cranes, powered by human workers or draft animals, could raise stone blocks and other materials to considerable heights. These devices used pulleys and counterweights to multiply the force applied by workers, allowing relatively small crews to handle very heavy loads. The operation of Roman lifting equipment required careful coordination and timing among the workers involved. Teams of men would work together to operate the lifting mechanisms, with one group managing the ropes and pulleys while others guided the load into position. The work was physically demanding and potentially dangerous, requiring experienced operators who understood how to use the equipment safely and efficiently. Roman cities were divided into neighborhoods with distinct characteristics and social compositions that reflected the economic and social structure of urban society. Wealthy citizens lived in spacious single-family houses called domus, which were typically located in desirable areas near the forum or on elevated ground that offered pleasant views and good drainage. These homes featured central courtyards surrounded by rooms for different family activities, private gardens where residents could relax and entertain guests, and elaborate decorations that displayed the wealth and status of the owners. The construction of a domus required skilled craftsmen and expensive materials, but the work was accomplished using the same basic tools and techniques employed throughout the city. Masons shaped stone blocks for foundations and walls. Carpenters built wooden frameworks for roofs and interior partitions. And plasterers applied decorative finishes to walls and ceilings. The entire process could take months or years to complete, depending on the size and complexity of the house and the availability of skilled workers. The majority of urban residents lived in multi-story apartment buildings called insula, which were built to maximize the use of available space while providing affordable housing for the growing urban population. These structures typically featured shops and workshops on the ground floor, with residential units on the upper floors. The construction of insula required careful planning to ensure structural stability and adequate light and ventilation for all residents, as well as proper access to water and sanitation facilities. The insulae represented a practical solution to the challenge of housing large numbers of people in limited urban space. They could accommodate dozens of families in a single building, with rent levels that varied according to the floor level and the quality of the accommodations. Ground floor units were typically the most expensive, as they offered easier access and were less affected by structural problems that might develop in the upper floors. Roman markets were carefully organized to serve the daily needs of urban residents while facilitating trade and commerce throughout the region. The market areas, called macella, were typically located near the forum and featured permanent stalls and shops where merchants could display their goods and conduct business with customers. The buildings were designed with attention to ventilation, drainage, and security, ensuring that perishable goods could be stored and displayed safely while protecting merchants' investments from theft and weather damage. Different types of merchants specialized in particular categories of goods, creating distinct sections within the market areas for different types of products. Butchers, bakers, and other food vendors were often grouped together in areas that had special facilities for handling perishable goods. Craftsmen who made pottery, metalwork, and textiles had their own sections where they could both manufacture and sell their products. The organization helped customers find what they needed while allowing merchants to benefit from the concentration of related businesses. Public spaces in Roman cities were designed to accommodate large gatherings and ceremonial events that were central to civic life and cultural identity. The Forum served as the primary gathering place for political meetings, religious ceremonies, and social events. But many cities also featured specialized venues for entertainment and cultural activities. Circuses provided space for chariot races and other equestrian events. Amphitheaters hosted gladiatorial contests and wild animal shows, and theaters presented dramatic performances and musical concerts. These entertainment venues were engineering marvels that could accommodate thousands of spectators while providing good sightlines and acoustics for everyone in attendance. The construction required advanced understanding of structural engineering, crowd management, and acoustic principles, all accomplished through careful design and patient construction using traditional building techniques and materials. The Roman amphitheater, with its distinctive oval shape and tiered seating, represented one of the most sophisticated building types developed in the ancient world. The structure had to support the weight of thousands of spectators while providing safe and efficient circulation for people entering and leaving the building. The Romans developed ingenious systems of corridors, stairs, and exits that could handle large crowds quickly and safely, even when the building was filled to capacity. The construction of large public buildings like amphitheaters required extensive planning and coordination among various groups of workers and craftsmen. Architects designed the overall structure and created detailed plans for the construction process. Engineers calculated the loads and stresses that the building would need to withstand. Surveyors laid out the foundation and ensured that the structure would be properly aligned and level. Masons, carpenters, and other craftsmen carried out the actual construction work under the supervision of experienced foremen.
Roman heating systems were ingenious solutions to the challenge of keeping buildings warm during cold weather, without the benefit of central heating systems powered by electricity or gas. The hypocaust system, which we discussed earlier in relation to public baths, was also used in private homes and other buildings where comfortable temperatures were important. The system used furnaces burning wood or charcoal to heat air that then circulated through spaces beneath floors and inside walls, providing even, comfortable warmth throughout the building. The operation of a hypocaust system required constant attention from slaves or servants who tended the furnaces, fed fuel to maintain proper temperatures, and monitored the system to prevent overheating or dangerous accumulations of smoke or carbon monoxide. The work was demanding and required experience to manage the fires safely and efficiently. The slaves who operated these systems developed specialized knowledge about fuel types, burning rates, and airflow patterns that was essential for the proper functioning of the heating systems. Lighting in Roman cities relied on oil lamps, candles, and torches that provided illumination for evening activities and nighttime travel. Public areas were sometimes illuminated during special occasions or festivals, but most streets remained dark after sunset, making travel dangerous and limiting the hours when commercial and social activities could take place. Private homes used small clay oil lamps that burned olive oil or other vegetable oils, producing a steady but modest flame that could light a small area for reading, cooking, or other activities. The manufacture of oil lamps was a specialized craft that required skill in working with clay and understanding the principles of combustion and airflow. Lamps were typically made in standard shapes and sizes, with a reservoir for oil, a wick holder, and a spout through which the flame emerged. The quality of the lamp affected both the brightness and duration of the light it produced, with well-made lamps burning more efficiently and producing less smoke than crude examples. Wealthy households might have dozens of oil lamps positioned throughout their homes to provide adequate lighting for evening entertainment and daily activities. The lamps were often decorative as well as functional, featuring carved designs, painted decorations, or sculptural elements that made them attractive additions to the home furnishings. The cost of oil and the labor required to maintain the lamps made artificial lighting a luxury that was available mainly to the wealthy. Roman workshops and commercial establishments organized their work schedules and physical layouts according to the limitations of available natural light. Blacksmiths,
Carpenters and other craftsmen arranged their work areas to take advantage of natural lighting from windows, doorways, and open courtyards. They positioned their workbenches and tools to maximize visibility during the hours when they could work most effectively. The most precise and demanding work was typically scheduled for the middle of the day when light conditions were optimal. Some workshops used mirrors made of polished bronze or other reflective materials to concentrate and redirect available light to specific work areas. These devices could significantly improve working conditions for detailed tasks like jewelry making, manuscript copying, or fine metalwork. The mirrors had to be positioned and adjusted throughout the day as the sun moved across the sky, requiring workers to understand the relationship between light sources and reflected surfaces. The Romans developed efficient systems for waste disposal that worked without mechanical equipment or powered transportation. Human waste was collected in sewers and carried away by flowing water to disposal points outside the city, where it was often used as fertilizer for agricultural crops. Solid waste, including food scraps, broken pottery, and other household debris, was collected by specialized workers who transported it outside the city walls for disposal or recycling. The work of waste collection and disposal was unpleasant and often dangerous, but it was essential for maintaining the health and cleanliness of urban areas. Cities employed teams of workers who cleaned streets, emptied latrines, and maintained the sewer systems that carried waste away from residential and commercial areas. These workers used simple tools like brooms, shovels, and carts to collect and transport waste materials. Roman cities featured numerous temples and religious buildings that served as centers of community life and spiritual practice. These structures were often the most elaborate and expensive buildings in the city, featuring fine stonework, decorative sculptures, and impressive architectural details that demonstrated the wealth and piety of the community. The construction of temples required the most skilled craftsmen and the finest materials available, but the work was accomplished using the same basic techniques employed in other construction projects throughout the city. The design of Roman temples followed established traditions that had been developed over centuries of religious architecture. The buildings typically featured a rectangular plan with columns supporting a triangular pediment, and the interior contained a statue of the deity to whom the temple was dedicated. The construction required precise measurement and skilled stonework to achieve the proportions and details that were considered appropriate for religious buildings. The Romans also built large public buildings called basilicas, which served multiple functions as courts, meeting halls, and commercial centers. These buildings featured high ceilings, large windows, and open interior spaces that could accommodate hundreds of people for various types of gatherings and activities. The construction required careful engineering to support the roof structure and create the desired acoustic properties that would allow speakers to be heard clearly throughout the building. The basilica design influenced later Christian church architecture and represented an important innovation in Roman building technology. The buildings used clear-story windows to bring natural light into the interior spaces, and the open floor plan could be adapted for various uses depending on the needs of the community. The construction techniques developed for basilicas were later applied to other types of large public buildings throughout the Roman world. Roman cities were planned to accommodate growth and change over time, with infrastructure systems designed to serve expanding populations and evolving economic activities. Streets and utilities were built with sufficient capacity to handle increased traffic and demand. Building lots were arranged to allow for expansion and modification of existing structures. The Romans understood that cities were dynamic entities that would need to adapt to changing circumstances, and they designed their urban infrastructure with flexibility and expandability in mind.
The planning for urban growth required careful consideration of future needs and potential problems that might arise as cities developed. Engineers had to estimate future water demand and design aqueduct systems that could be expanded or supplemented with additional sources. Planners had to consider how increased traffic would affect street systems and whether additional thoroughfares would be needed to handle the flow of people and goods. The maintenance of Roman cities required ongoing effort and resources from municipal governments and private property owners. Streets needed regular cleaning and repair to remain safe and passable. Aqueducts required constant monitoring to ensure proper flow and water quality, with workers inspecting the channels, clearing blockages, and repairing damage from weather or settling. Public buildings needed regular upkeep to remain safe and functional, including roof repairs, wall maintenance, and replacement of worn fixtures and fittings. All of this maintenance work was accomplished by teams of workers using traditional tools and techniques. Street cleaners swept debris and removed obstacles that could impede traffic. Aqueduct workers walked the entire length of the water channels, checking for leaks, blockages, and structural problems. Building maintenance crews repaired roofs, walls, and other structural elements using the same materials and methods that had been used in the original construction. Roman cities were connected to each other and to the wider empire through an extensive network of roads that were built to the same high standards as city streets. These roads featured multiple layers of construction, careful attention to drainage, and durable paving that could withstand heavy traffic for decades. The construction of roads required surveying to determine the best routes, earth moving to create proper grades, and paving work that was accomplished entirely by hand using traditional tools and techniques. The Roman road system facilitated trade, communication, and military movement throughout the empire, connecting urban centers with rural areas and enabling the flow of goods, people, and ideas across vast distances. The roads were built wide enough to accommodate military units, commercial caravans, and civilian travelers, with regular staging posts that provided accommodation and fresh animals for long-distance journeys. Trade and commerce were essential to the success of Roman cities, and urban areas were designed to facilitate the efficient movement of goods and services. Markets, warehouses, and workshops were strategically located to serve both local residents and traveling merchants who brought goods from distant regions.
The infrastructure supported various types of economic activity, from small-scale crafts and retail trade to large-scale manufacturing and distribution operations. The Roman economy depended on the smooth functioning of urban commercial centers that connected producers and consumers across the empire. Cities served as collection points for agricultural products from the surrounding countryside, manufacturing centers for finished goods, and distribution hubs for luxury items imported from distant regions. The success of this system depended on reliable infrastructure that could handle the daily movement of large quantities of goods and people. The standardization of construction methods also facilitated the movement of skilled workers between different construction projects and regions. A mason who had learned his trade in Rome could apply his skills to building projects in Britain or North Africa, confident that the basic techniques and standards would be familiar. This mobility of skilled labor was essential for the rapid expansion of Roman urban development throughout the empire. Roman cities were designed to serve multiple functions simultaneously, reflecting the complex needs of urban society and the integrated nature of Roman civilization. They were centers of government, where local officials administered justice and collected taxes. They were commercial hubs, where merchants traded goods from throughout the empire. They were religious centers, where citizens worshipped the gods and participated in festivals and ceremonies. They were cultural centers, where people gathered to enjoy entertainment and participate in intellectual discussions. This multifunctional approach required careful planning and flexible design that could accommodate diverse activities and changing needs over time. Buildings and spaces had to be designed to serve multiple purposes, and infrastructure systems had to be robust enough to handle the demands of various types of activities. The success of Roman cities depended on this integration of functions and the ability of urban infrastructure to support the complex web of activities that characterized Roman urban life. The Romans understood that successful cities needed to be sustainable over long periods, capable of adapting to changing circumstances while maintaining their essential functions. They built infrastructure that could withstand natural disasters like earthquakes and floods. They designed systems that could accommodate population growth without major reconstruction. They invested in maintenance and repair programs that would preserve their investments for future generations. This long-term perspective influenced every aspect of Roman urban planning and construction, from the initial site selection to the final details of building decoration. The sustainability of Roman cities also depended on their relationship with the surrounding countryside, which provided food, raw materials, and markets for urban products. Roman planners understood that cities could not exist in isolation, but needed to be integrated into regional economic and social networks. They built transportation systems that connected urban centers with rural areas, facilitating the exchange of goods and services that sustained both urban and rural populations. Roman cities were also centers of learning and culture, featuring schools where young citizens received education in reading, writing, mathematics, and rhetoric. Libraries preserved books and scrolls containing the accumulated knowledge of the ancient world. Intellectual gathering places provided venues for philosophical discussions and scholarly debates. These institutions required specialized buildings that could accommodate their particular needs while fitting into the overall urban fabric. Libraries needed to protect books and scrolls from damage caused by moisture, insects, and fire, while providing adequate natural light for reading and copying manuscripts. The buildings typically featured stone construction for fire resistance, carefully designed ventilation systems to control humidity, and large windows positioned to maximize daylight during reading hours. The storage systems for books and scrolls were designed to make materials easily accessible while protecting them from damage. Schools required spaces for instruction that could accommodate groups of students while providing good acoustics and lighting conditions. The buildings often featured colonnaded courtyards where classes could meet in pleasant outdoor settings during good weather. Indoor spaces were designed with attention to ventilation and lighting, ensuring that students and teachers could work comfortably throughout the day.
The Romans developed sophisticated systems for managing urban populations, including census-taking procedures that tracked the number of residents, taxation systems that funded public services, and administrative structures that coordinated municipal government activities. These functions required office buildings, record storage facilities, and meeting spaces for officials and citizens. The construction of government buildings followed the same principles as other Roman architecture, emphasizing durability, functionality, and appropriate scale for their intended purposes. Administrative buildings needed secure storage for important documents and records, as well as meeting spaces where officials could conduct public business. The buildings were typically constructed with thick stone walls for security and fire resistance, and they featured multiple rooms designed for different types of administrative functions. The architecture was usually dignified but not overly elaborate, reflecting the serious nature of government business while avoiding unnecessary expense. Roman cities featured elaborate systems of public entertainment that reflected the importance of leisure and spectacle in Roman society. Theaters presented dramatic performances, musical concerts, and recitations that entertained and educated urban populations. Circuses hosted chariot races and other equestrian events that drew crowds from throughout the region. Amphitheaters presented gladiatorial contests and wild animal shows that became synonymous with Roman culture. These entertainment venues required sophisticated engineering to accommodate thousands of spectators safely and comfortably. The buildings needed to provide good sight lines from every seat, adequate acoustics for performances, and efficient circulation systems for managing large crowds. The construction involved complex calculations of loads and stresses, careful attention to structural details, and innovative solutions to architectural challenges. The Roman theater, adapted from Greek models, featured a semicircular seating area built into a hillside or supported on arched foundations. The stage area included a permanent backdrop with multiple levels and architectural details that enhanced the visual appeal of performances. The acoustic properties of these buildings were carefully designed to carry the voices of actors to every seat without amplification, requiring precise attention to the shape and materials of the performance space. Public health was a major concern in Roman cities, and urban planners paid careful attention to factors that affected the health and safety of residents. Clean water systems prevented the spread of waterborne diseases. Effective sewage removal eliminated sources of contamination and unpleasant odors. Proper waste management kept streets clean and reduced the risk of disease transmission. Public baths promoted personal hygiene and provided opportunities for exercise and social interaction. The Romans also understood the importance of air quality in urban environments and designed their cities to promote good ventilation and reduce pollution from cooking fires and industrial activities. Streets were laid out to take advantage of prevailing winds that would carry smoke and odors away from residential areas. Industrial activities like metalworking and pottery making were often located on the outskirts of cities, where their emissions would not affect the general population. The Romans developed effective systems for fire prevention and control in their cities, recognizing that fire was one of the greatest threats to urban populations. Buildings were constructed with fire-resistant materials when possible, including stone walls and tile roofs that would not easily ignite. Streets were designed to serve as fire breaks that could prevent the spread of fires from one building to another. Some cities maintained firefighting equipment and trained personnel who could respond quickly to fire emergencies. Fire prevention also involved regulations governing construction methods and materials, as well as restrictions on activities that could create fire hazards. Buildings were required to meet certain standards for wall thickness and roof construction. Activities involving open flames were regulated or prohibited in certain areas. Property owners were responsible for maintaining their buildings in safe condition and providing access for firefighting efforts if needed. Roman cities were designed to accommodate diverse populations with different needs, preferences, and economic circumstances. Residential areas featured various types of housing, from luxurious villas with private gardens and elaborate decorations to modest apartments that provided basic shelter for working families. Commercial districts offered a wide range of goods and services, from expensive luxury items imported from distant regions to everyday necessities produced by local craftsmen. Public spaces were designed to be accessible to all citizens regardless of their social status or economic circumstances. The Forum served as a meeting place where rich and poor could interact on relatively equal terms. Public fountains provided clean water to everyone. Public baths offered opportunities for hygiene and relaxation that were available to citizens of all social classes, though different facilities might cater to different economic levels. The Romans paid special attention to the relationship between their cities and the surrounding countryside, understanding that urban and rural areas were interdependent parts of a larger economic and social system. Urban markets provided outlets for agricultural products, while cities supplied manufactured goods, services, and cultural amenities to rural populations.
Transportation networks connected urban and rural communities, facilitating trade and communication between different parts of the region. This integrated approach to regional development required careful planning and coordination between urban and rural authorities. Roads had to be built and maintained to handle agricultural traffic during harvest seasons. Markets had to be organized to accommodate the seasonal rhythms of agricultural production. Storage facilities had to be provided for crops and other products that would be distributed throughout the year. Roman urban planning also considered the need for emergency services and disaster response, recognizing that cities faced various types of natural and human-caused threats. Cities were designed with multiple access routes to facilitate evacuation if necessary during military attacks or natural disasters. Public buildings were constructed to serve as emergency shelters during crises, with strong walls and adequate space for large numbers of people. Food and water storage facilities were strategically located throughout cities to ensure that supplies would be available during emergencies or sieges. Granaries stored wheat and other staple foods that could sustain the population during periods when normal supply chains were disrupted. Water storage tanks provided reserves that could be used if aqueduct systems were damaged or contaminated. The legacy of Roman urban planning extends far beyond the ancient world and continues to influence contemporary city development. Many modern cities still follow street patterns that were established by Roman engineers nearly 2,000 years ago. The grid system that organized Roman cities became a standard model for urban layout that has been adopted throughout the world. The principles of urban design developed by the Romans, including the integration of residential, commercial, and public spaces, remain fundamental to modern city planning.
The infrastructure technologies pioneered by the Romans laid the foundation for later developments in water management, sanitation, and public works. Roman techniques for building aqueducts influenced the development of modern water supply systems. Roman methods for constructing sewers provided models for urban sanitation systems that are still used today. Roman innovations in concrete and construction techniques contributed to the development of modern building technology. Archaeological evidence continues to reveal new information about Roman construction techniques and the sophistication of ancient urban planning. Excavations of Roman sites throughout Europe, North Africa, and the Middle East have uncovered evidence of advanced engineering, careful planning, and high-quality craftsmanship that demonstrates the skill and knowledge of Roman builders. These discoveries help us understand how the Romans accomplished their remarkable building projects using only hand tools and manual labor. Recent archaeological work has revealed details about Roman construction techniques that were not previously understood. Excavations have uncovered evidence of sophisticated lifting devices, complex scaffolding systems, and innovative construction methods that allowed Roman builders to create structures of unprecedented size and complexity. These findings have increased our appreciation for the ingenuity and skill of ancient craftsmen. The Romans left behind extensive written records describing their construction methods and urban planning principles, providing valuable insights into the thinking and practices of ancient builders. These documents include technical treatises on architecture and engineering, government records detailing public works projects, and personal letters describing construction activities. The writings of architects like Vitruvius provide detailed information about Roman building techniques and design principles. These written sources complement the physical evidence revealed by archaeological excavations, creating a comprehensive picture of Roman urban development. The combination of textual and material evidence allows modern scholars to understand not only what the Romans built, but also how and why they built it. This knowledge helps us appreciate the complexity and sophistication of Roman civilization. Roman cities were built to last, and many of their structures have survived for nearly 2,000 years, despite wars, earthquakes, and the effects of weather and time. This durability is testament to the quality of Roman construction and the effectiveness of their building techniques. The longevity of Roman infrastructure demonstrates that sophisticated urban development was possible long before the advent of modern technology and power tools. The survival of Roman structures also reflects the care and attention that went into their design and construction. Roman builders understood the importance of using appropriate materials, employing proper construction techniques, and building structures that could withstand the stresses and forces they would encounter over time. They invested in quality rather than speed, creating buildings that would serve their communities for generations. The Romans understood that cities were more than collections of buildings and infrastructure systems. They were communities of people who needed to live, work, and interact together successfully over long periods of time. Roman urban planning reflected this understanding by creating spaces that facilitated social interaction, economic activity, and civic participation. The physical design of Roman cities supported the development of complex urban societies that could adapt and thrive in changing circumstances.
The social aspects of Roman urban design included attention to the needs of different groups within the population, from wealthy elites to working families to slaves and foreigners. Public spaces were designed to accommodate various types of activities and social interactions. Residential areas were planned to provide appropriate housing for different economic and social classes. Commercial areas were organized to serve the diverse needs of urban populations. Modern engineers and architects continued to study Roman construction techniques and urban planning principles, finding lessons that remain relevant to contemporary urban development challenges. Research into Roman concrete has led to new understanding of material science and construction chemistry. Studies of Roman urban design have influenced modern approaches to sustainable development and environmental planning. Contemporary research has revealed new insights into Roman engineering practices and confirmed the sophistication of ancient building methods. Modern analysis techniques have allowed researchers to understand the composition and properties of Roman materials in ways that were not previously possible. These studies have increased our appreciation for the scientific knowledge and technical skill of Roman builders. The story of Roman cities reminds us that human ingenuity can overcome significant technical limitations through careful planning, persistent effort, and collaborative work. Without electricity, power tools, or modern machinery, Roman builders created urban infrastructure that served millions of people for centuries. Their achievements demonstrate the power of human creativity and determination applied systematically over long periods of time. The Roman example also shows us that successful urban development requires more than advanced technology. It requires understanding of human needs, careful attention to environmental factors, and commitment to quality and durability. These principles remain as relevant today as they were 2,000 years ago, reminding us that the fundamentals of good urban planning transcend specific technologies or historical periods. Roman cities were built through the collective effort of thousands of workers laboring together over many years and decades. Each project required the coordination of numerous specialists, from architects and engineers who designed the projects to skilled craftsmen who carried out the construction work, to common laborers who performed the routine tasks that made large-scale construction possible. The success of these projects depended on effective organization, clear communication, and shared commitment to quality and excellence. The collaborative nature of Roman construction projects created opportunities for workers to learn from each other and develop their skills through practical experience. Young workers learned their trades by working alongside experienced craftsmen, gradually taking on more complex and responsible tasks as their skills developed. This apprenticeship system ensured that technical knowledge would be preserved and transmitted to future generations. The Romans created cities that were both functional and beautiful, serving practical needs while inspiring civic pride and cultural achievement. Their urban environments supported diverse populations, facilitated economic growth, and provided venues for intellectual and artistic expression. These accomplishments were achieved through traditional construction methods applied with exceptional skill, dedication, and attention to detail.
The aesthetic qualities of Roman cities were not merely decorative additions to functional infrastructure. They were integral parts of urban design that served important social and psychological functions. Beautiful public spaces encouraged civic participation and community pride. Impressive buildings demonstrated the prosperity and sophistication of the community. Attractive environments improved the quality of life for all residents, regardless of their social or economic status. The quiet efficiency of Roman construction methods offers lessons for contemporary builders and planners who face similar challenges in creating sustainable, livable urban environments. Roman techniques emphasized the efficient use of local resources, the application of time-tested methods, and the importance of building for long-term durability rather than short-term convenience. They demonstrated that impressive results could be achieved through patient, systematic work using relatively simple tools and techniques. Roman construction also emphasized the importance of understanding local conditions and adapting general principles to specific circumstances. Roman builders modified their standard techniques to accommodate different climates, available materials, and local preferences, all while maintaining the essential characteristics that made Roman cities successful. This flexibility and adaptability were key factors in the success of Roman urban development throughout the diverse regions of the empire. As we conclude our journey through the Roman world, we are left with a deep sense of admiration for the builders who created these remarkable cities through patient, skillful work carried out over many generations. Working without the benefits of modern technology, they accomplished feats of engineering and architecture that continue to inspire us today. Their cities stand as monuments to human creativity, persistence, and the power of collaborative effort applied to ambitious long-term projects. The Romans built their cities one stone at a time, one day at a time, with patient attention to every detail of design and construction.
They understood that great accomplishments require sustained effort over long periods, and they were willing to invest the time and resources necessary to create infrastructure that would serve future generations. They valued quality over speed and understood that the investment in excellence would pay dividends for centuries to come. Tonight, we have walked through the streets of ancient Rome and its sister cities throughout the empire, observing the careful work of builders who shaped the urban world with their hands, simple tools, and accumulated wisdom passed down through generations of craftsmen. We have seen how they brought water from distant mountains through carefully engineered aqueduct systems, built roads that connected continents and lasted for centuries, and created public spaces that fostered community life and civic participation. Their achievements remind us that human beings can accomplish remarkable things when they combine technical knowledge with persistent effort and collaborative spirit. The Roman cities were testaments to the power of shared vision, careful planning, and dedicated work applied consistently over long periods. They showed that urban civilization could flourish without modern conveniences when communities were willing to invest in quality infrastructure and maintain it properly over time. The Roman cities were built without electricity, but they were filled with the energy of human ambition and creativity, channeled through practical skills and organizational ability. They were constructed without power tools, but they were powered by the determination of people working together toward common goals that would benefit their communities for generations. They rose from empty fields through the application of ancient wisdom and timeless principles of good design adapted to local conditions and available resources.
In the quietness of this evening, we can almost hear the sounds of ancient construction sites where Roman builders worked steadily to create the urban world that would serve as the foundation for Western civilization. The ring of hammers on stone as masons shaped blocks for walls and pavements. The creaking of wooden scaffolds as workers climbed to install roof tiles and decorative elements. The voices of workers calling to each other across construction sites as they coordinated their efforts and shared their knowledge and experience. These sounds have faded into history, but their legacy remains in the cities that still bear the mark of Roman planning and engineering. The principles they developed continue to guide urban development, and the infrastructure they created continues to serve communities throughout Europe, North Africa, and the Middle East. Their influence extends far beyond the physical structures they built to include the ideas and methods that made their achievements possible. The Romans showed us that cities could be both grand and livable, impressive and practical, beautiful and functional. They demonstrated that urban life could be civilized and comfortable even without modern conveniences when communities were planned carefully and built with attention to human needs. Their cities were places where people could live safely, work productively, and participate in the cultural and political life of their communities. The Roman approach to urban development emphasized the importance of long-term thinking and investment in quality infrastructure that would serve multiple generations. They understood that cities were not temporary expedients, but permanent features of the landscape that would need to adapt and evolve over time. This perspective influenced every aspect of their planning and construction, from the initial site selection to the final details of building decoration and public art. As we drift towards sleep, we carry with us images of Roman streets paved with carefully fitted stones,
public fountains flowing with clear water brought from distant springs, and public spaces filled with the quiet activities of daily life in a well-ordered urban community. We remember the patient work of builders who shaped stone and mixed concrete, who surveyed land and laid foundations, who created the infrastructure that made urban civilization possible. The Roman cities were built to human scale, designed for people walking at the pace of pedestrians and draft animals rather than the speed of automobiles and trains. They were illuminated by the sun and moon rather than electric lights, heated by wood fires and solar gain rather than fossil fuels, cooled by stone walls and flowing water rather than mechanical air conditioning. They were places where the rhythms of human life could unfold naturally within the framework of well-designed urban spaces.
Sleep comes easily when we contemplate the steady, methodical work of Roman builders and the enduring results of their patient craftsmanship. Their achievements teach us the value of persistent effort applied consistently over long periods. Their skill reminds us that excellence is possible in any age when people are willing to invest the time and attention required to master their crafts. Their cities stand as proof that human beings can create lasting works of beauty and utility through careful planning and dedicated work. In the morning, we will return to our modern world of electric lights and power tools, computers and automobiles, but tonight we rest in the quiet contemplation of an ancient world where cities were built by hand, one stone at a time, with patience and skill that we can still admire across the centuries. The Romans built their cities without electricity, but they filled them with the enduring light of human achievement that continues to illuminate our understanding of what urban communities can accomplish when they commit themselves to excellence and long-term thinking. The legacy of Roman urbanism extends beyond the physical structures they created to include the principles and methods that guided their work. They showed us that successful cities require more than impressive buildings and advanced technology. They need clean water, effective waste management, safe transportation, and public spaces that bring communities together. They need to be planned with attention to human needs and built with commitment to quality and durability. These lessons remain as relevant today as they were 2,000 years ago, reminding us that the fundamentals of good urban design transcend specific technologies or historical periods.